In this video, we'll cover how to create a bend table for a bent tube that's associative to a model. In part one of this series, we created the tube, so if you haven't seen that, you may want to go back and watch that because we took some steps there that we'll be utilizing to help create the bend table. So now we'll switch over to our drawing. So I've pre-created a drawing here. We'll first add our views, so we'll click Base View, and we'll add a front view here, and then we'll do a projected top view, right side view, and then we'll add one more base view, and we'll add a trimetric. So we'll add that. Then we may want to add center lines. So I want to move this over a little bit. I'm going to select that, everything in that view, Control middle mouse to apply, select everything in that view, middle mouse to apply, and then select everything in that view, and then we'll select OK. So we could dimension this out, but in this case, we want to show how to do a bend table. So our points aren't showing yet. So if we go to the Assembly Navigator, select the tube, right-click, replace reference set with points, and then now we'll need to update our views. So we'll click the Update button, and we notice we have the points in all these views now. So if we zoom in, we can see that a little better. And maybe we don't want to show the points over in this trimetric view. So one way, since we added those points on a layer, we can just hide that layer in the view. So if we go to the View tab, the layer group, and then select the More, and then there's a command called Layer Visible in View. We'll select that. It's asking us in the Q line, we see choose view to change layer visibility. So we'll choose the view. And now if we just type in 70 and press enter, then that layer 70 becomes invisible. If it shows visible, if it showed visible there, we could select it and click invisible, and then click OK, and then we'll just cancel out of this dialog. So now our trimetric view doesn't have those points shown. So moving on, we're ready to create our bend table. So I'll zoom in on that. We've kind of got a template started down here, but we want to populate this with our X, Y, and Z points and our bend radius, and we want it to be associative. So I'm going to switch over. I'm going to stay in this file, but switch to the modeling application. So I'm going to press the M key. That'll switch to modeling. I'm going to double click the background to zoom to fit. And so the first thing we'll do is we'll create measurement points at each of those bend points. So I'm going to open the measure tool. I'm going to set it to point, and then I'm also going to make sure existing point's the only option for the snap. And then I'm going to select that point, middle mouse to apply, the next point, and we may want to set it to static wireframe or wireframe so we can see our points a little bit better. I'm going to select the next point, middle mouse to apply, next point, middle mouse to apply, next point, middle mouse to apply, and then our final point. And then we'll select OK. So now we have 5 points here, and there's expressions created for each of those points. So I'm going to close this information window, go back to shaded view. If we open expressions again, Control E, and we switch to show all the expressions, we can see now we have measurements representing the X, Y, and Z's for each of those points. There is an option in the measurement tool to break out the X, Y, and Z's, but in the method we're using, we don't want to do that. So we're going to create those later. So if I type in, I'm going to rename these just so I'll know which point's which. So point 1, I'm going to do point 2. You get the idea. Point 3. Oops. Point 3. Point 4. And point 5. So now we have them labeled, and we need to extract our X, Y, and Z's. So I'll select OK there. I'm going to switch back to drafting, so Control-Shift-D. We'll switch back to the drafting application. I'm going to open up expressions in here. If you try to open expressions and it's not available, there's a customer default. So I'll show you File, Utilities, Customer Defaults. And then under Drafting, General Setup, if we select the Miscellaneous tab, there's Allow Expressions. So if you select this, if it's not on to begin with, you'll select that, hit OK, and then you'll have to restart NX so that it applies. But after setting that customer default, we can press Control E to get to our expressions. So we're going to create expressions for our X, Y, and Z's for each of these points. I'm going to show a couple of them manually, but just know we don't have to do them all manually. There's a faster way. So I'm going to name the first one 0.1_x. And so there's a function in NX called NX _x, and that basically extracts the x value from a point. So I'm going to do 0.1, and then I'm going to do the next expression just to show a second one. We'll call this 0.1_y, if I can keep my caps going. And then we'll do NX. We'll start typing NX, and we see there's the function NX _y that pulls the y value, and we'll just pull the y value from 0.1. So we've got our first couple there, and we notice it's pulling the x and y values from 0.1. But there's an easier way. We can import these expressions so we don't have to go through and type them all. So to start with, I'm going to export what we have so we can kind of see what it is. So if we export, I'm just going to call this tube expressions and say OK. And then I'm going to actually go and open that one we just created. Just any note editor will work. And so here's what we have. So here's our measurement points. We can see those, and this measurement point 1. But here's the ones we just added to extract the x, y, and z. So essentially, we just need a list like this: 0.1x, 0.1y, 0.1z, 0.1, 0.2, x, y, z, etc. So I have a spreadsheet over here already kind of created for generating that. Once you generate it once, you can just save the expression and reuse it in all your drawings. But let me just drag this down. We'll get at least to where we have 5 points. There we go. And so here's our expressions that we need for our 5 points. So I'm just going to copy that. This is what the string is going to look like. We'll switch back to our note editor. I'm just going to delete all this and paste in those expressions. And then we'll click Save. Now if we go back over to NX, we can import expressions. And we're going to select that file we just created. Select OK. And so now we see we have our measurement, the x, y, and z values, measurement, x, y, and z values, measurement 0.3, x, y, and z values. So we've got all our expressions that we want. Now we just need to populate our table. So I'll select OK there. We'll zoom in on our table. We could populate this manually. I'll show you a couple, but again, especially if you have a lot of points, that could take a while. But I'll show you the manual population of it just to see the method, but then we'll do kind of an automatic way. So I'm going to right-click that cell, say Edit Text. And once the text window opens up, we can click Expressions, and we'll just expand the default group. We'll select 0.1x, select OK, and that's associated to our x value of 0.1. And then the same thing for the bin radius. So for the bin radius, we'll right-click this cell, say Edit Cell. And in this case, when we choose expressions, the bin radius isn't in this drafting file, this drawing file. So I'm going to say Link to Part, and we're going to choose our tube part. So this one here, select OK. And I'm going to scroll down until I see tube bin radius. So right there's tube bin radius. I'll select that, select OK. And then OK once again. So there's our tube bin radius. So it creates an inner part expression between your tube part and your drawing part. So that's kind of the method we would use. If we double click this, we can kind of see the syntax. But instead of manually going through and doing all these, what we can do is if we go to the top left of the tabular note, we right click, we can say Edit Using Spreadsheet. And so this will bring up this table in an Excel window. Sometimes it takes a couple of seconds. So if we drag this over here to where you guys can see it, we kind of see the table that we have here. And if we click on this, we can kind of see the expression that it's using. It's called expression val is the function, and then 0.1x. And then the same thing, if we click here, expression val, and then tube radius. So I've already pre-created kind of the same thing, pre-created a thing to build that out over here. And again, once you build this out once, you can just save it and you can use it on all your tube drawings. So I'm just going to drag this down so that we get all these expressions. I won't go into how I created this, but you can either do it manually or you can do it with formulas. But I'm going to just copy basically everything there that's going to populate our table. So I'm going to Control-C there, switch back to our other Excel table, and I'm going to paste in, let me make sure I didn't get the headers. Yeah, didn't get the headers, so I'm going to just paste in that there. You may get a warning. You don't need to worry about that. Just click OK. And then when I exit this spreadsheet, it'll say, do you want to update the contents? And I'm going to say okay. And we'll notice now our table's populated with all our values that we wanted, but obviously we may not want to show a million decimal places. So what we can do to solve that is if we just highlight these columns, we'll right click and select cell settings. We'll switch, instead of text, we'll switch it to number, and let's put in for our decimal places 3, and then we'll hit close. So now we've got 3 decimal places, and then if we wanted to show just one for this column, we can right click, do cell settings again, and we could switch to 1 decimal place. And so there's our table. One thing I like to do after I get done editing the table in spreadsheet, I like to go to the top left, right click, and say edit without spreadsheet. This way, when someone clicks on this to edit it, it's not going to open that spreadsheet again. So now if we wanted to edit, we could edit directly there. And now that we've got our table, we got to kind of verify that it's associative. So we'll make a edit to maybe one of the locations of this 0.5 X value. So right now we're at 45.6. We'll go here, and to edit that last point, we'll come to this coordinate system. We can even do it in this window here. So we were at 45. So if we do 20, that should add 5 more inches to our X value. Come back to our drawing, and now we see we're at 50, and we can update our drafting views. And so there's our bin table. It's associative to the model. It takes a little bit of setup the first time, but once you have it set up, you don't have to redo those steps. All you have to do is create the measurement features and then name them. And then you can already have, for instance, if I had an expression with already 8 bins built up, we just have to import this if we name our points the same. So we don't have to recreate that. And the same thing for the populating the tabular note. If we pre-create, so we could have a static thing over here, so we could pre-create these expressions to populate the tabular note with and just paste that in. So even though it seems like a lot of setup, it is the first time, but once you save that, you can just reuse these strings for your expressions and reuse this for your table over and over again. As long as you have more points than what you need, you can just delete off what you don't need. So if we switch back to NX now, there's our associative table with our bin radius, and I forgot this, your first bin radius and last bin radius. There isn't one, so I'll put not applicable there, and same thing here, NA for this one. So we'll fit the screen and we'll save our drawing. To recap, in part 1 we created the tube model, and in part 2 we created our bin table that's associated to that model.